Hi everybody. Today I'm going to be going over Chapter 4, Question 34 from the Bingo Problems. So first of all, I'll read the question because there's a lot of information in there that is good to know. So it says, an oil tanker's engines have broken down and the wind is blowing the tanker straight towards a reef at a constant speed of 1.5 meters per second. When the tanker is 500 meters from the reef, the wind dies down just as the engineer gets the engines going again. The rudder is stuck, so the only choice is to try to accelerate straight backwards away from the reef. The mass of the tanker and cargo is 3.6 times 10 to the 7 kilograms, and the engines produce a net horizontal force of 8.0 times 10 to the 4th newtons on the tanker. Will the ship hit the reef? If it does, will the oil be safe? The hull can withstand an impact at a speed of 0.2 meters per second or less. Ignore the retarding force of the water on the tanker's hull. So, and then it also gives a diagram that I kind of drew very rudimentarily just to get the point across. So here's our tanker, 500 meters from the reef. The velocity is 1.5 meters per second. The force is the 8.0 times 10 to the 4th newtons going that way. And the total mass of the tanker and the cargo and everything is 3.6 times 10 to the 7th kilograms. So part A was talking about the distance traveled. So with the information we're given, we need to figure out how far this is going to go. Because obviously if it goes less than 500 meters, then we're safe, right? It didn't hit the reef. But if it goes more than 500 meters before stopping, then we know that it's going to hit. And so from there, what we need to use is this distance formula. So x equals the velocity squared over 2 times the acceleration. Since we're not given the acceleration, we're given the velocity, we will substitute the force over mass for the acceleration, which will give us this. So now what we need to do is just plug in these values to find out what that distance is that that tanker goes before it's able to stop. So x, write that a little bigger, x equals, so the velocity is 1.5 meters per second squared, I'll erase this just to have more room, over 2 times 8.0 times 10 to the 4th over the mass So now that we've filled everything in, the only variable we have in the whole equation is the x, so we know that we can just solve it using simple algebra. You put that into your calculator, you end up getting that x equals 506 meters, I guess 506.25 meters. So what does that mean? So this means that the distance it takes to stop is greater than the distance that we have till the reef. So we know that the ship is going to hit the reef. So part A, it will, I'll just say it. Okay, so we know that the ship hits the reef. And so part B then asks if the ship does hit the reef, if the cargo's safe. And it says that it's safe if it hits with a velocity of less than 0.2 meters per second. So now we'll use another one of our equations. And we'll plug everything in, see what the velocity is at the end of all this, and if it's less than or equal to 2.0 meters per second, we'll know that the cargo's safe. So let's plug in the values that we have. So alright, and so this x here is the distance that we're looking for. So we're looking at the distance that the ship is hitting right as it's hitting the reef, right? Because that's going to give us the velocity right at that point. So make sure that as you're doing this problem, you don't put in this x, because this x is different. This is our value for how far the ship would go if the reef wasn't there. Since the reef is there, we know that the x is only 500 meters. So make sure to remember that, otherwise your numbers are going to be crazy. So we have this. The next step, we need to square root, since this is velocity squared. So we'll just take the whole square root of all this. We'll just call that v final. So square root of this, and now we only have one variable, so it's just down to the simple math at this point. So we plug this into our calculator, make sure that we get it all in there and underneath the square root sign, and we end up with that velocity equaling 0.17 meters per second. So since 0.17 is, definitely less than 2.0, we know that the cargo is going to be safe. So thanks for watching. Hope you learned something. Hope you check out my other videos, and we'll see you next time. Thanks.